Hi guys, so in a previous video we had shown the following fact that the integral from 0 to infinity of e to the negative t times x to the n over 1 plus x to the n dx is equal to e to the t times the gamma function of n plus 1 divided by n times the incomplete upper gamma function of n minus 1 over n with parameter t. Now if we let t go to 0, then we can just substitute in 0 for this part, and this bit here, and interchanging limits and so on is allowed because of the dominating convergence theorem. This thing has a dominator which is just 1 over 1 plus x to the n, so we're able to just put it in and put t equal to 0. Now if we do this, we get the integral from 0 to infinity of e to the 0 for everything on the top, which is 1, and then we live with 1 over 1 plus x to the n dx, and on the right hand side e to the 0 is just 1. This thing stays the same, and then the last term becomes a regular gamma function, so we get gamma n plus 1 divided by n multiplied by the gamma function of n minus 1 over n. Now we can expand this slightly, so we get gamma of 1 plus 1 over n times gamma of 1 minus 1 over n. And now using the gamma function's identity, gamma 1 plus z equals z times the gamma function of z, we can expand the first term. So we end up with gamma of 1 over n times the gamma function of 1 over n times the gamma function of 1 minus 1 over n. And now we use the Euler reflection formula, which is this. So the gamma function of z times the gamma function of 1 minus z, this is equal to pi divided by sine of pi times z. In our case, we have z equal to 1 over n, which means when we do this, we get 1 over n times pi divided by sine of pi times 1 over n, just substituting in z equals 1 over n, and then simplifying this down, we have pi divided by n times sine of pi divided by n.